been exposed to composition of functions before? Maybe you didn't. I mean, you probably learned composition of functions right at the same time as you learned function notation in the first place, and maybe having just learned function notation and what a function is and everything, it doesn't click right away. When you learn what a function is, you learn it's a rule, or they talk about a machine or something, but I mean it's some kind of a rule. This function f here says take an x value and square it. So if you took a number like 3, you get a number like 9, or if you take a number like 5, you get a number like 25. G is also another thing, right? G is a different rule here. It says if you put a number in, you multiply by 2 and subtract 3. So if you put a number like 7 in, you multiply by 2, you get 14. Subtract 3, you get 11. Composition of functions is putting those two things together, just applying those two rules in sequence. The notation is this, right? This f of g of x. You could write it with larger brackets. I guess I didn't need the brackets around the outside there, but f of, you could use square brackets of g of x. It just means take an x value, apply this rule g to it, and then apply the rule f to the result that you get. So essentially it's put a number into this function, to g, because it's the inside function. We can talk about inside and outside functions. It's the inside function. So it's the first one you apply. So if you take a number like 4, you put it into g and you get, what do you get with 4? Multiply by 2, subtract 3, you get 5. Then you take that result and you put it into the other function. Okay, you don't put the original value in. You put the y value, or the resulting value from g, into f, and what do you get? You square it and you get 25. The notation is that, or with bigger brackets, right? F of g of x. Or there's the other notation down at the bottom, this g of f of x. It looks like you're multiplying here. This is another notation. I kind of like the first thing here, this nested brackets, one inside the other, to emphasize that you're applying one, then you're applying the other one. But some people write it like this. This is still g of f of x. That looks really good, doesn't it? G of f of x, g. Right? Okay? You're still just doing that. When there's a value in there, right? This G with the circle, this is not an O. This doesn't say goff. This doesn't say fog. Maybe that's how you want to remember it, but that's how it is written sometimes, just so you know that it's not multiplied. And when you're doing that, you can't put the value in. If I wanted to do G of f of negative 1, I would write G of f of negative 1 like that. If you want to work this out, you can do what I did up here, which is just apply the rules one at a time. Or you can come up with a function once and then apply it. You can come up with the function algebraically. If you want the function for g of f of x, you can come up with it algebraically, right? You can take g of x, which is 2x minus 3, but you can replace this, right? You can take an x value. Let's do this first. There's an x value. We're first going to apply this function f. That function says square the number, right? And then you apply this function g to it. What does that say to do? Take the result. So take that, times it by 2, subtract 3. That's g of f of x. I think when you learned it, you probably learned write out the outside function and then instead just replace the x with whatever that function is, right? X squared. Either way you look at it, you get the same thing. All right, that's composition of functions. Composition functions on the graphing calculator. If you want to teach yourself this, all it's going to do is save yourself some button pushing, right? Like if you've got two functions here and you don't want to write the whole thing out again, you can do that. You can experiment with that yourself if you want. The second thing in this section is one-to-one functions. A one-to-one function. When you first learn about functions, you learn this vertical line test and this sort of thing. If you have something like this, that could be some kind of a function, something that oscillates up and down like that. It's a function because for any one x value here, if you pick this, if this is 3, let's say it has a y value of 7, right? There's only one y value for that x value. One y value for each x value. That's what a function is. Oops, lost my function. Start again. You learned about you could do this vertical line test. If you take a vertical line, it's just a way of checking, a visual way of checking, right? Anywhere you put the vertical line, it only crosses the thing once, which means anywhere you put it, any x value you pick, there's only one y value. A one-to-one function means the relationship works the other way as well, right? If you say it with words here, 1y for each x, right? That's what makes it a function. Okay, that's what a function is. If you're saying it's one-to-one, it means it's the reverse as well. It means if you pick this x value, it has one y value, but if you pick one y value, it only has one x value. Is this function one-to-one? Like when we, it's not, right? When you pick an x value, sure, there's only one y value for that. But when you go the other way, if you pick this y value, there's two x values, that one and that one, right? There's an x value, there's another one. This is not a one-to-one function. If it turns around like that, if it goes up and then back down again, it's not going to be one-to-one because for any one y value, it's almost like you can do a horizontal line test, right? You can check it with a horizontal line because that crosses that thing twice. If you want to have a one-to-one function, or for something to be a one-to-one function, it kind of has to either go up or down, or can't turn around like that. Anywhere you look at this now, for any one y value, there's only going to be one x value. It's only going to cross it once. All right? Anywhere you put this thing, why is it not moving? Anyways, I think you get it. Okay, anywhere you put that thing, it's only going to cross the thing once. That one is one-to-one. It's just a term to use if you happen to if you happen to read it in the book or something, just so you know what a one-to-one function is. There's a few different functions down there. You can decide for yourself after whether they're one-to-one functions or not. And the third thing in here is inverse functions. I'm actually going to stop this and then start it again.